Hello, my name is Francesco Scotto di Luzio. I am a postdoc at the Research Unit of Advanced Robotics and Human-Centered Technologies, and I will present our project HeAL, an intelligent rehabilitation robot for physical and cognitive interaction. Robots are adopted in rehabilitation because they are able to deliver highly intensive and repeatable motion therapy for both neurological and musculoskeletal disorders. The aim of rehabilitation is the motor and functional recovery of the region of interest, the restoration of range of motion, and the recovery of muscular strength. In more recent studies, the assistance provided by the robotic platform has been changed based on patient biomechanical and psychophysiological state with interesting results. To our knowledge, the efficacy of a robotic platform in a real scenario, able to provide both physical and cognitive support to the patient with neurological or musculoskeletal disorders, has not yet been investigated in the state of the art. The aim of our project is the development and validation of an intelligent rehabilitation platform able to promote the motor relearning, providing support to the patient through motor, physiological, linguistic, and emotional cognitive interaction. More in detail, our platform will be composed of a service robot able to replicate the patient behavior, will also autonomously adapt to the patient state, and will establish a verbal, physical, and cognitive interaction with the patient. Our project will be based on the observer-demonstrator approach, composed of three different phases for each rehabilitation tasks. In the first phase, the therapist has to demonstrate the task, and the patient has to observe the movement of the therapist. In the second phase, the therapist will observe the movement performed by the patient. And in this case, patient will be the demonstrator. In the last phase, therapist will help patient only if needed. In this scenario, the healthcare operator has to establish also a physical and cognitive relationship with the patient, and his or her intervention cannot ignore the patient's clinical and emotional state. From this point of view, in order to develop an effective robotic system, robotic platform for rehabilitation, it could be useful to analyze and reproduce the patient-therapist interaction. As seen before, the robotic platform will play one role among demonstrator, observer, and helper. The robot will also demonstrate the motor task to the patient, and it will constantly evaluate the motor performance of the patient. Moreover, learning by demonstration approaches allow encoding the patient-therapist interaction, physical interaction, and also retarget the recorded motion onto the robotic platform. The cognitive interaction will be managed by a dedicated set of modules devoted to the acquisition of input from the environment, to the tracking of the whole dialogue and the planning of individual reactions. Just to conclude this brief presentation, our project has the ambition to design, develop, and validate in a real scenario a robotic system for rehabilitation able to replicate physical and cognitive interaction with the patient. This objective poses numerous technological, scientific, and also ethical challenges, but the important results may reveal whether and at what extent the use of a robot integrating physical and cognitive capabilities can be a valid tool to improve the effectiveness of the rehabilitation treatment in patients affected by musculoskeletal disorders. Thank you for your attention.